When we heat the surface of the ocean, we create a layer of hot water at the top. And that layer of hot water at the top is sitting on a colder layer at the bottom. A lake is very similar to that. That region, that interface between the hot layer and the cold layer is called a thermocline, because in that region we have a rapid change in temperature, maybe 1 to several degrees from the warmer water to the colder water. So a thermocline, this area of rapid change in temperature, actually just represents an interface, the boundary between two water parcels with different temperatures. Okay? In the upper ocean, that layer above the thermocline is called the surface mixed layer. And it's called the surface mixed layer because it takes on its own independent properties. That surface mixed layer tends to be mixed up because of winds blowing. It tends to have very similar properties from the surface down to the thermocline. It's called mixed because it's mixed up. And it exhibits very specific chemical, biological, and physical properties versus the water below it. So I want to introduce here two terms: the thermocline, this boundary between two layers, and the surface mixed layer, the upper part of the ocean above the surface mixed layer. And another important aspect of this is that that surface mixed layer is cut off, not completely cut off, but exchanges between that surface layer and the water below it are very minimal. So there's very little that's exchanged across that thermocline. So in terms of physical, chemical, and biological properties, the surface layer is going to be very distinct from the layer beneath it. The thermocline begins to develop as the ocean gains heat. When does the ocean gain heat? If we think about our own experiences, when does it begin to warm up? During the seasonal cycle, during the springtime. So as sun angles rising, as days are getting longer, as the intensity of solar radiation per unit area is becoming more intense, the surface of the ocean begins to warm up and a thermocline forms. And that thermocline is called the seasonal thermocline. That absorption of that heat may be slowed down if we have winds or any other processes that distribute that heat deeper, but ultimately that thermocline develops, and it's the rate of heating and mixing that determines how quickly and how strong or what the gradient of temperature is across that thermocline. The very top of the thermocline defines the depth of the surface mixed layer, called the mixed layer depth. So from the surface to the thermocline, and again, the warm water, the surface mixed layer, sitting on top of colder water, here's the thermocline. This depth is called the mixed layer depth. Okay? And as we go from wintertime, where we have completely mixed water column, and it begins to warm up, we begin to form a thermocline that actually gets shallower and shallower, and as we'll see, the mixed layer depth gets shallower and shallower because we're heating it up and creating really a series of thermoclines. Okay, so that's where we're going with